When sizing conductors for a 100 amp service to a barn, it's essential to understand the relevant tables in the National Electrical Code. Table 310.15b6 is indeed specifically for dwelling services and feeders, and since a barn or lean-to is not a dwelling, that table does not apply. The correct table to use in this scenario is Table 310.16. This table provides ampacities for conductors rated 0 to 2000 volts and is applicable to general-purpose branch circuits and feeders. It's not limited to dwelling services only. For a 100 amp service, using THHN conductors, you need to consider the ampacity at the 75 degrees Celsius column. THHN insulation has a rating of 90 degrees Celsius, but the termination temperature ratings often limit the conductor ampacity to that of the 75 degrees Celsius column. This is a common practice and important to remember. Looking at Table 310.16, a number 3 THHN conductor has an ampacity of 100 amps when rated for 75 degrees Celsius. Therefore, using number 3 THHN conductors is the correct choice for a 100 amp service in this application. Remember that this applies under specific conditions such as ambient temperature. Corrections and adjustments may be required. It is also important to ensure that the overcurrent protection device, such as a circuit breaker or fuse, is appropriately sized to protect the conductors. In this case, a 100 amp overcurrent device should be used. Grounding and bonding are also critical aspects of the electrical installation. Ensure that the grounding electrode system is properly installed and that all metal enclosures and equipment are bonded according to the NEC requirements. This will help to minimize the risk of electrical shock and ensure the safe operation of the electrical system. The location of the barn in Louisville, Kentucky does not impact the ampacity calculations. However, local amendments to the NEC should always be considered. Always consult with a qualified electrician to ensure that the electrical installation complies with all applicable codes and regulations. Firstly, consider the type of load the barn will serve. Is it primarily lighting, receptacles, or will there be any heavy equipment such as welders or motors? The total load calculation will influence the service size and conductor selection. Secondly, consider voltage drop. While number 3 THHN is adequate for 100 amps, if the barn is a significant distance from the service point, voltage drop calculations may be necessary to ensure that the voltage at the barn is within acceptable limits. If excessive voltage drop is present, a larger conductor may be required. Thirdly, check for any local amendments or requirements that may impact the conductor sizing. Some jurisdictions may have specific rules or regulations that go above and beyond the NEC. Fourthly, remember to consider the equipment grounding conductor. The size of the equipment grounding conductor is based on the size of the overcurrent protection device protecting the circuit. Refer to NEC Table 250.122 for the appropriate size. Fifthly, ensure that all wiring methods are suitable for the environment in the barn. If the wiring will be exposed to moisture or corrosive elements, use appropriate wiring methods such as PVC conduit or liquid-tight flexible metal conduit. Sixthly, properly support and secure the conductors. Use appropriate cable ties, straps, or conduit supports to keep the wiring neat and organized and to prevent damage. Seventhly, label all circuits clearly. Use circuit directories to identify the load served by each circuit breaker. This will make it easier to troubleshoot problems in the future. Eighthly, perform a thorough inspection after the installation is complete. Check all connections to ensure that they are tight and secure. Test all circuits to ensure that they are functioning properly. Ninthly, keep a record of the electrical installation. This should include a wiring diagram, a list of all materials used, and the results of the inspection and testing. Tenthly, consider future expansion. If there is a possibility that the barn will be used for more demanding purposes in the future, it may be wise to install a larger service and conductors now to avoid having to upgrade the system later. Also, it is worth noting that the 75 degrees Celsius column in Table 310.16 is most commonly used due to the temperature limitations of the terminals on breakers, switches, and other equipment. While the wire itself may be rated for 90 degrees Celsius, you must use the lowest temperature rating of any component in the circuit. Therefore, the 75 degrees Celsius rating is the most common and safest choice. In addition, consider the ambient temperature where the conductors will be installed. If the ambient temperature is higher than 30 degrees Celsius, you may need to apply correction factors to the ampacity of the conductors. These correction factors are provided in the NEC. Make sure the conductors are installed in a manner that allows for proper heat dissipation. Avoid bundling conductors together or running them through insulated walls, as this can reduce their ampacity. When working with electricity, always exercise caution and follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize circuits before working on them whenever possible. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Understanding the correct application of Table 310.16 is crucial for ensuring the safety and reliability of electrical installations. It provides the necessary guidelines for selecting the appropriate conductor size based on the ampacity requirements of the circuit. Remember to always consider all relevant factors such as ambient temperature, voltage drop, and termination temperature ratings to ensure that the electrical system is installed in accordance with the NEC and local codes. Moreover, it is always beneficial to refer to the latest edition of the National Electrical Code for the most up-to-date information and requirements. Electrical codes and standards are subject to change, and staying informed about the latest revisions is crucial for ensuring compliance and safety. Remember to consult with a qualified electrical inspector to verify that the installation meets all applicable codes and regulations. Furthermore, it's worth mentioning that other types of conductors besides THHN can also be used for this application. However, the ampacity of the conductor will vary depending on the type of insulation and its temperature rating. For example, conductors with higher temperature ratings, such as XHHW-2, may have higher ampacities. Always refer to Table 310.16 to determine the appropriate ampacity for the specific type of conductor being used. The use of proper connectors is also essential for ensuring a safe and reliable electrical connection. Use connectors that are listed and labeled for the specific type and size of conductor being used. Follow the manufacturer's instructions for installing the connectors. Avoid over-tightening or under-tightening the connectors, as this can damage the conductors or create a loose connection. When making connections in a panel board or junction box, be sure to leave enough slack in the conductors to allow for future maintenance or modifications. Neatly arrange the conductors and secure them with cable ties or other approved methods. This will help to prevent accidental contact with energized parts and make it easier to troubleshoot problems in the future. Also, keep in mind that the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that the wiring should be installed in a way that is aesthetically pleasing and easy to understand. Avoid creating unnecessary splices or bends in the conductors. Use proper supports and fasteners to secure the wiring in place. Label all circuits clearly and accurately. In addition to the conductor sizing, it is also important to consider the size of the conduit or cable through which the conductors will be run. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit or cable. Refer to the appropriate tables in the NEC to determine the maximum fill for the specific type of conduit or cable being used. Overfilling a conduit or cable can damage the conductors and create a fire hazard. When installing conduit, be sure to use proper bending equipment to avoid kinking or damaging the conduit. Support the conduit at appropriate intervals to prevent sagging or damage. Use approved fittings and connectors to make connections between conduit sections. Also, consider the impact of derating factors when multiple conductors are installed in the same conduit or cable. The NEC requires that the ampacity of the conductors be derated when more than 3 current-carrying conductors are installed in a raceway or cable. The derating factors are provided in the NEC and are based on the number of conductors and the ambient temperature. Remember to apply the appropriate derating factors to ensure that the conductors are adequately sized for the load. Finally, it is essential to have a thorough understanding of the NEC and local codes before starting any electrical work. The NEC is a complex document, and it is important to stay up to date on the latest revisions and interpretations. Consider taking continuing education courses or attending seminars to enhance your knowledge of electrical codes and standards. By following these guidelines and tips, you can ensure that the electrical installation in the barn is safe, reliable, and compliant with all applicable codes and regulations. Always prioritize safety when working with electricity, and never hesitate to seek the advice of a qualified electrician if you have any questions or concerns. In summary, correctly sizing the conductors for a 100 amp service to a barn or lean-to requires a thorough understanding of the NEC, specifically Table 310.16. This table applies to general-purpose circuits and feeders, not just dwelling services. Number 3. THHN conductors with an ampacity of 100 amps at 75 degrees Celsius is the correct choice for this application. However, remember to consider other factors such as ambient temperature, voltage drop, and directing factors to ensure that the electrical system is safe and reliable.